Hello there, this is Dr. Dell, and this is the third interlude in the book Teaching Math that you are reading now that I wrote. And of course, you can learn a lot more about all of this stuff at triadmathinc.com. I want to talk to you today about the third triangle problem that I mentioned in this book. And this is one that I really enjoy a great deal. I ask you very simply, if you have a triangle that measures 3, 4, and 6 units, say inches, on each of its three sides, what is its area to say within two decimal places? And of course, the answer turns out to be 5.33. Now, this turns out to be a deceptively difficult problem. In fact, it's if somebody's asking me, well, will I learn anything in your practical math foundation course? Will I really learn anything? I say, well, here's a problem. See if you can do it. And if a person can solve this problem in 5 minutes or less, and come up with this answer, then my answer to them is you probably aren't going to learn too much. You know a lot of practical math. You'll learn some things probably that you don't know, and you certainly may learn some things in terms of content and pedagogy if you're a teacher. And indeed, if you are a teacher, I would expect that you could solve this very easily within 5 minutes. Any student that goes through the foundation is usually able then to solve it in a minute or less using, of course, a calculator. We do all of our calculations with the scientific calculator. And indeed, without a calculator, this would be quite time consuming to solve. And there's various ways you can solve it if you happen to know something called Heron's formula, which, by the way, I didn't even know that until I read about it in Dr. Simmons' pre-calculus book. He has some very interesting things in there that I didn't know, and it's one of the reasons I love that book. But I prefer to use trigonometry. And it turns out that it's not too difficult to do. We learned, in fact, one of the earlier interludes that if you knew the angle between, say, the sides 3 and 4, that was angle A, then here would be a formula that would get it. It would 0.5, 1/2 times 3 times 4 times the correction factor, which is the sine of angle A, which I told you about in the first interlude. But our problem now is we don't know angle A. Now, if I told you angle A was 117.3 degrees, then bingo, you could get that using this formula, but you don't know. And now the question is, how do you find angle A? Now, I must say I've given this problem previous during the geometry and trig section, so people realize that they couldn't solve it with what they knew. One of the things that's very important in math is to know what you don't know, or to know when you're not able to solve a problem. Sometimes it's because you're not given enough information, and sometimes it's just because you don't know how to do it. You don't have the right tools, perhaps, or you don't know how to use the tools. So in this case, it turns out that the generalized Pythagorean theorem, which is what I call it, also called by most people the law of cosines, is the key to that. Now let me show you a little more detail then how we handle that. In the course, the practical math course, which this is the notebook that we use, and I've already told you in some previous interludes, and in fact you can download this syllabus right off of the triadmathinc.website if you want to see this syllabus. If you're a teacher and you want to kind of do what I'm doing on your own, then here's the syllabus. It's kind of like a lesson plan of what I use, and we go through the calculator and the pre-algebra first, then the algebra, then we go through geometry, and indeed, now you can go through all of this and you still can't solve that problem. Not easily anyway. It'd be difficult to. And then we get into trigonometry, and this is really the very last thing we teach in trig, is this what I call generalized Pythagorean theorem, or law of cosines. And so let's take a quick look at it. Here this is T7, and I point out that we know the Pythagorean theorem already. So if our angle was 90 degrees, the Pythagorean theorem would give us the answer. But it's not 90 degrees, and many times, of course, it's not. And so again, we need a correction factor. I like to talk about correction factors to give them an idea. So we start with the Pythagorean theorem, and then we subtract 2 times A times B times cosine of that angle, and that is the correction factor. And then now you've got an equation that works for all triangles, and I call that the generalized Pythagorean theorem because it's kind of the Pythagorean theorem, except now you've added a correction factor, so now it'll work for any angle, not just a right angle. And of course, once you've done that, you can now use the algebra you've already learned in the algebra section to solve for the cosine of AB. And then you've also learned how to take the inverse cosine to get the angle, and that is indeed then how you solve the problem. And that's what we teach you to do in the foundations course. Now, I didn't prove this. I just gave them this as a formula that will always work. It's kind of like when you do mathematics and practical math, sometimes you'll look up a formula in a manual or a handbook, or it'll be on documentation. And you have to know how to use it, whether you understand where it came from or not. So in this case, I just say this works. However, if you want to know why this works, if you want to see, quote, a proof of it, then you're going to find that in Tier 3. Because when we get into Tier 3, which is Dr. Simmons' book, then back in the trigonometry section, we will then give a very simple proof of this. As you know, if you're a teacher, the key to proving this is to use a two-dimensional analytical geometry setup and to use the, well, I'm not going to go through it now, but it's very easy to prove using analytical geometry techniques, which you get into in Tier 3 in this book. Now, there's some proofs in this book that are so subtle and deep that I don't even do them in Tier 3. I wait till Tier 4. However, this is one of those proofs that's really quite easy to do. We'll prove the law of the cosines and the law of sines, along with a lot of other things, in Tier 3. So when the student gets through this book in Tier 3, they will have done about 80% of it, and they will know how to prove a lot of these things. And of course, once you know how to prove it, sometimes that makes it easier to remember it. But for now, they just remember it. So that's what we do in the foundation. We teach them this, we teach them how to solve this problem, and when they get done with this, there is virtually no problem involving triangles that a student cannot solve. If you give enough information to solve it, then they'll be able to do it. Sometimes they have to use the law of sines, sometimes they have to use the law of cosines. And I'm just going to show you one other thing that is important that you need to do if you're a teacher. We give them a warning and we give them some motivation for it about the inverse sign and the fact that the inverse sign has two values between 0 and 180 degrees. And we show them a couple of examples of that so they can understand. Sometimes when you're using the law of sines, you can get confused if you don't understand that if you take the inverse of this number here, for example, the calculator will show you 72 degrees, but it will also 108 degrees, the supplementary angle of 72, would give you the same sign. So really there's two answers for the inverse sign, and you got to know which one to use. And we have a whole section on that because that is something that can lead to error in practical math if you don't know that. So this is Dr. Dell. I just wanted to tell you about that, and we will have another video on another interlude coming up, and I'll see you on that interlude. Bye-bye.